Good morning and welcome to lesson 6.1. Yes, we're starting chapter 6 today. 6.1 is split up into two parts. We're going to do part 1 today. And we're looking at, as you can see, the rules of exponents. So we're just starting some of these rules. We have about 5 rules coming our way this morning. And it should be rather a shorter lesson today. And maybe a little bit of review. Let's hope. All right, so how do I use rules for exponents? Well, the first one we're going to look at is the zero and the negative exponent rules, and you can see the core concepts sitting down here in the square, the rectangle. And the zero exponent rule is described as a to the 0 equals 1, and that's where a is not 0, so I wouldn't have 0 to the 0. That's not defined. And here's a clear example if you'd like more definition on that. So the negative exponent rule says if I have some base raised to a negative exponent, it becomes 1 over that exponent. Now, what you might want to jot this one down too. What would happen if my base or my power is down below as a negative? Then it comes up above and becomes like a to the n over 1, which we know just can be written as a to the n. So a negative exponent moves from top to bottom or bottom to top is the essential piece of it. Here's a clear example if you want to see that. Jot a couple of those down in your notes and let's do some problems. So using the 0 and negative exponents, 6.7 to the 0, well, anything raised to the 0 is 1. This letter B and letter C are written a little bit differently. 1, I have the negative included in the parentheses, and that is raised to the 0. This will turn out to be 1. This is really telling me take the entire number, negative 6.7, and raise it to the 0. That gives me 1. Where in B, the only thing raised to the 0 is the 6.7. So this negative is still hanging around and we'll get negative 1. Maybe use those arrows and boxes like I did so you can clearly see why we come in with a negative 1 as an answer. These are tricky questions and they definitely will appear on a quiz and a test. So definitely, know the difference between A, B, and C. For D, I have a negative exponent, and that negative exponent says if we're in a numerator position, like 3 to the negative 2 is, then it'll become 1 over 3 to the positive 2. And we know that simplifies to 1 over 9. For E, it is a numerator. I could put this over 1, right? So the negative exponent here, not the negative number, negative 2, but rather the negative on the 4 makes this 1 over negative 2 raised to the 4th. Well, that becomes 1 over 16. Why is that? Because I'd have negative 2 times negative 2 times negative 2 times negative 2. And we know that if I have a negative times a negative, I get a positive, and another negative times negative, I'll get a positive. So this would be 1 over 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. I'll also show you how to put that in your calculator in a moment. F. Well, now we're sitting in the denominator, aren't we? Notice that this power is in the denominator. This negative exponent's going to move it to the numerator. So it'll just push up above. Don't really need to write the 1 underneath it. We'll get 25 as an answer. You try these. So take a moment, try these, and come back, hit pause on your video, and come back and compare your answers. Okay, here are my answers. Letter G, I got 1. Letter H, I had 1/8. The negative exponent moved it to the bottom. And I has a couple things going on. Negative 5 to the 0. Well, the only thing raised to the 0 is the 5. So the outside negative hangs around. I get negative 1 there. 2 to the negative 2. Well, that negative is going to push us up above. So I got 2 to the positive 2 in a numerator. And negative times 4 gives me negative 4. All right, example 2, simplifying an expression. Here, an expression, this means we're going to have, we could possibly introduce some variables here And when I look down below here, I see I have lots of variables going on. So x to the 0, that's still going to be 1. Anything raised to the 0 is 1. Y to the negative 7 means this is going to be 1 over y to the 7th, the negative moving it down below. Let me change colors here. X to the 0 is going to be 1, so I'm going to get 4 times 1 will be 4. Y to the negative 3, now I'm going to deal with that negative 3, which will move it up above. Final answer, 4y cubed. Oh, it's not traveling well. All right, letter D and E, try on your own. Hit pause and come back. Here are my answers. For letter D, the first thing I did was simplify y to the 0 as 1. Then I took these negative exponents and pushed them to the denominator. And then I finally squared the 3, got 9x to the 5th. On E, the first thing I did was simplify 2 to the 0, made that 1. That left me an x squared over a y negative 2. And then the y negative 2, of course, is going to push to the top as a power of y squared. All right, example 3, using properties of exponents, we pick up 3 more properties. Here, if I have the same base, a and a, or 4 and 4, I can combine these and simplify it. So if I have a to the m power times a to the n, it becomes a to the m plus n. I add those exponents. Here's a concrete example if that helps. Quotient. Quotient, of course, means division. So if I have the division of powers, and just let's clarify, a to the m is considered a power. Now I know a lot of times we refer to m as the power, but really m is the exponent. So the power is the entire entity a to the m. So when this says a quotient of powers, this is a power, and this is referred to as a power in math. So a to the m over a to the n, we subtract those exponents. Here's a concrete example. And power to a power, I have a raised to m as well as n. So I get a to the m times n. And we multiply those, getting us 3 times 6, or 4 to the 18th. All right. Once you get those done, you might want to hit pause if you're not quite done recording those. But here's some examples. So I have a product of 2 powers. The bases happen to be 3, and they are the same, which means I can push these together and use addition, and that'll give us 3 to the 8th. Now, 3 to the 8th, that's a lot of 3's to multiply. So let's go to our calculator and key it in there. So key in 3, use your caret key. Now, I'm on a graphing calculator. You may be on your scientific, but for both, there should be a caret key or a raised power key. And let's put our 8 in, and we get 6,561. Next, negative 4 raised to the 2 and negative 4 raised to the 7. We have a quotient going on. We got division, don't we? Our bases are indeed the same. So this becomes like this rule for quotients. I'm going to take my base, negative 4, and raise it to the m minus n. The top exponent minus the bottom exponent. Of course, that's going to give me a negative 4 raised to the negative 5. We know what a negative exponent does. It makes it 1 over. So I'll have negative 4 raised to the 5th. And if I don't want to multiply 4 out 5 times, let's use our calculator. Now on this one, definitely get the negative 4 into your parentheses so that the, whoops, I didn't do it, that the negative gets raised to the 5th power as well. Gets us an answer of negative 1,024. Okay, the next one, it appears to use the power of a power property. So power of power. And for that property, we can see that we should multiply our exponents. So I get z raised to the negative 12th. Oh, we encounter a negative rule. So that's going to be 1 over z to the 12th. They're kind of fun, don't you agree? Honestly, using variables makes it almost easier. Okay, there's several for you to try. I'm going to run through them. If you want to do them on your own and then just, fast forward to find the answers, that'd be great too. I'll try to do them quickly here. I have two bases that are the same and multiply. I'm going to use the product of power rule. That means we are going to add these exponents. That's going to give us 10 to the negative 2. And then we're going to implement the negative exponent rule, which will make it a positive down below. And we all know that 10 squared should be 100. Looks like 1 over 100. For B, I'm going to add my exponents, 9 plus a negative 9. Ooh, that sounds like it's going to zero out, doesn't it? And anything raised to the 0 is 1. So we used two different rules, didn't we? All right, this on C, I get negative divided by negative is positive. The negative is not raised to a power, is it? Because it's outside. If we wanted it raised to the 8th or to the 4th, parentheses would have been included. So in this case, I'm just going to say negative over negative is positive. I have a quotient going on, don't I? 5 to the 8th divided by 5 to the 4th means I subtract those exponents. Gives me 5 to the 4th. If you don't want to do 5 times 5 times 5 times 5, or maybe don't have it memorized, then let's use our calculator and go 5 raised to the 4th, 625. Okay, I see a quotient again. That means I'm going to use the quotient rule because the bases are the same. That's going to give me y, 6 minus 7, y to the negative 1. Negative exponent rule kicks into effect, and I get 1 over y. Power to a power is this next one, isn't it? That's going to give us 6 to the negative 2 times the negative 1. 6 squared, oh, we all know, that's 36. Power to a power, another time where we multiply these two. Well, let's use parentheses. 12 times 5, if you don't know it, plug it in your calculator, but we get w to the 60th. All right, homework. Homework 296, and you can print this out from Schoology or use your note packet, which some of you have and don't have. All right, so you can view this PDF on Schoology as well. Good luck.